Radical Dude here, and today we're going to talk about multiplying two binomials. We're going to take a binomial times a binomial, and we're going to see how we multiply it. If you want to know what a binomial is, check out my video on polynomials. I think I already filmed that one. Anyway, what we're going to do is I'm going to show you two ways to do this. One with algebra and one with geometry. And hopefully by the end, it'll make things a little bit easier for you. So, the easiest binomials I'm going to write are these. Let's do x plus 3 times x plus 2. Okay? Those are the two binomials we're going to multiply. What I do very simply is this one. I take this x, I pretend like two people are going to the party. These are two people going to the party. These are two people at the party. What happens when they get together? We introduce them. So, I'll tell this x, hello x, I want you to meet my two friends, x plus 2. So how does he meet them? Well, x times x using the distributive property is x squared, and x times 2 using the distributive property is 2x. Now I tell 3, here comes 3, I want you to meet my two friends, x plus 2. So I put the x plus 2 right there. So I say 3 meet x. Well, 3 times x is 3x. And 3 times 2 is 6. Now what do? We put equal signs because these all are related. What do we do next? We combine like terms. What is like terms? They're terms that are similar that you could put together. Just say you're at the party. This guy's talking about x squared. There's no one else talking about x squared. So he stays alone. But this guy's talking about x. And this guy's talking about x. So we put them together, right? Don't you do that naturally at a party? You say, hey, you like this? Well, this person likes the same thing. You two have to meet. So this 2x and this 3x make 5x. And then 6, it's just a numeral. He has no friends. He stands alone. And there you go. That's your trinomial. Now another way with the algebra that teachers like to use is called the FOIL method. FOIL. It stands for first. You do the first terms. That gets you the x squared. Then you do outer. These are the outside terms, x and 2x. That gets you this. You do the inner. Those are the inside terms. And you do the last, whatever's last. And that gets you the 6. And then again, you combine like terms. So that's proving it algebraically. Now let's try geometrically. Here we go. I'm going to make a nice rectangle. Right? The area of the rectangle's length times width. Everybody knows the area is length times width. That's not a big deal. Well, let's break off a section. Let me just call this section, make it like the flag. I'll call this x and x. Now remember, I want the whole length to be x plus 3. That means this is a 3 right here. So this distance for this whole thing is x plus 3. And the other multiplying that I was going to do, the other binomial, is x plus 2. That makes this a 2. Now, all I do is break this up into sections. This is x plus 3, which is the length, times x plus 2, which is the width. And now, what we do is take the area of each rectangle. Well, this rectangle is a square, so x times x, x squared. That's no big deal. The area of this one is 3 times this distance here. Well, what is this distance here? It's x, right? These are all x's. This is an x, this is an x. So the area of this rectangle right here is 3 times x, 3x. So far, so good. What's the area of this rectangle? Well, it's 2 times this distance. Well, what's this distance? It's the same as that. It's x. So the area of this is 2 times x. 2x. And now the last part is right here. Well, this distance is 3, right? Because from here, this is 3. The same thing here. This is 3. And then what's this distance? Well, this length is 2. These are 2. And what's the area? Length times width is 6. So what's the area of the whole thing? Well, you're taking x plus 3 times x plus 2, right? That's length times width. And you just add these boxes. X squared, no other terms to combine it with. You have a 2x and a 3x, gives you a 5x. And a 6 is left over. And there it is. So that's a geometric proof of multiplying 2 binomials. Right there. This has been Radical Dude, and I hope I was able to teach you something. Thank you.